Hello? Can you hear me now? Okay, yeah, now it's listening to me. I was explaining this whole time, and you couldn't hear me because my mic wasn't picking up for some reason. I will have to record over that when I put this on YouTube. So, as I was explaining, this program basically recreates this tree from data about this map, and it finds the shortest path. So if I scroll back down to the final tree, it returns an object for this node right here, which then can be used to find the information for this entire path. So, something that I need to do now is this right here. It returned all the right information, but notice how it says end and start? That's because my teacher wants me to make it so that it lists them out in order from start to finish, and the way I currently do it has finish to start. So I'm going to have to fix that. So the first thing I'm going to do is I'm going to need to create a new function. Public, let's make this a list. Integers, and it would be get path, and why doesn't it like that? Oh, because I'm not returning anything. So let's integers. Output equals new list integer. Return output. And it doesn't like that I'm creating a list because I can't create a list. I need to create an array list. Okay, so what I'm going to need to do now is is there a way to add to the beginning? Output dot add. Nope, just add to the end. I can deal with that. What am I gonna have to do? Probably add all, and then root dot get path. Let's put an if statement here so that actually, if the root is wrong, so root equals null. So basically, if the current node is at the top of the tree, so this A node right here, it doesn't have a parent, so its root would be null. So this is saying if root is null, so if this is the parent, then don't then do this. Actually, I want to, if it's not null, so if this is not the parent, then go and get the parent, else it would throw an error. So then I need to do else output dot add this dot id. Actually, I don't want that. I want that to do that either way. So let's try this. If path equals null, so if path is null, then that means it couldn't find anything. Then I want to print path not found. Else Oh, I don't like that. Let's put that in the same line. There we go. Else for integer I in path dot get path. Not in. That is C# syntax. I don't want that. I'm not used to Java, so I keep putting in C# syntax. System.out.println I. Okay, this should work, hopefully. So if I run this again, 1 to 2, kind of. So what I actually want to do is I want to go backwards. So I want to list integer path. Nope, I already have a path. Let's call this path, and let's call this result. And that equals result.getPath. Can I reverse the order? If I can, that would be so useful. Nah, I'm not gonna do that. I'm just gonna do it the easy way. Int I equals path dot size -1. I is greater than or equal to 0. I minus. Okay. And I want to print path.get I, and if this isn't the last node, so I is less than greater than 0, then I want to print the dash. And the only thing left to do is I now need to print out the distance. So system.out.print that would be bracket and what's next? Result.f and that goes end node and bracket again. And then let's just copy this. It'll be faster. Okay, so this prints out the distance. The f function is what this is on all these nodes. Then it prints out each item and then goes to the next line and then starts to loop all over. So if I restart the code and do 1, if I type in the terminal instead of my file, and 2, it goes, what? Why is it? Why is it still going in the wrong order? Oh no, it was going in the right order before. Okay, so that's not a problem. I is less than path.length path.size minus 1. And let's make this equal to 0 less than path.size. Oh, and I++. There we go. Restart this. I type in 1, I type in 2, and it goes from 1 to 2, and it shows the distance. Yay! That's correct. Last things last, let's make it actually ask for a file. Or ask for both files, I guess. And we're done. That was the program. I know I had most of it already done when I started. I can run through my algorithm quickly. If I find the right function. Here we are. Okay, so it creates the trunk node. Then it adds the trunk node to the leaves. Then it cycles through until leaves is empty, or it finds the right node. And when I say finds the right node, I mean the right node has to be at the beginning of leaves. So then it gets the first node of leaves, and it creates a list of branches from that. So let's say it gets this S, it creates nodes for A, F, O, and R. It removes any that loop. So this ASA would not be valid because it loops back to A. So you might as well just start at A. So there's no point. Because if I let it, then it could just keep following this path over and over and over again. Which, 1, we don't want because we don't like infinite loops, and 2, that would not be the shortest path, so it would be pointless anyway. So it then only returns F, O, and R. Then adds them to leaves, and it removes the one that was currently working on. So since S now has branches, it's no longer considered a leaf, because a leaf is a node in the tree without any branches. So it removes it. Then it sorts it so that it knows which one has the shortest path, and it loops back again. If, let's say we were going with this Bucharest example, if there were no connections to Bucharest, then what it would do is when it got to this P, this Bucharest won't be listed, and this Bucharest over connected to this F won't be listed. And it would just keep going, and eventually it will remove all the leaves, because it will try to create branches. All the branch options would be loops, so it would remove them, and then it would, even though it wouldn't be able to, even though what's remaining would still technically be a leaf, because it doesn't have any children, that leaf would have been explored thoroughly and wouldn't be a valid option, so it would still remove it. And it would sort it, and eventually there will be nothing in there, so when it sorts, it will just be done automatically. Go back to the beginning of the loop, say, hey, that's not, this list is empty, so we break the loop, and if it is empty, it returns null. If it's not empty, it returns the first item. And so back up to here, then we get the result. If it's null, that means it couldn't find it, so it says path not found. Else, it prints out all this stuff that I just told it to. I just wrote down. So I guess one last thing that I'm going to do is create a new function called print path. And that will take node path. And if I go up here and copy this in, then all I would have to do is print path result, which I guess I can just now call it path again. Let me organize this. And it doesn't like that that's lowercase, so I'll make it happy by making it capital. And then paste this in here. Let's call this path node. Clean up this code. Oh, I also need int key. Let's just call it key. Scroll up here, add that. And if we run it again, it should work perfectly fine. There's now 2 extra steps though, because I added in the file selection again. So edge weights would be edge weights.csv. Heuristic files would be min costs.csv 1 to 2, and it gets the right path. Now it loops back around to enter again. So I want Wikipedia edge weights. And what's in that file is, it's the same thing, but it's a smaller graph, and it's from information I found on Wikipedia. So actually, if I go to Wikipedia, I can a star search. And it's that example right there. Except I modified the file so that so I called these nodes 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I removed the connections to 5. So when I run this, and I say I want to go from 1 to 5, it says path not found. So yes, it is working the way I wanted it to. That is good. So I guess my assignment is now done.